so they call this seeing structure. I guess that's kind of ambiguous and not very clear. So I guess what we're going to think about is, well, you remember order of operations, right? PEMDAS. Okay. Who can tell me what they think when you're solving an equation? Are you actually using order of operations the way you normally would, or are you doing something different? Like how? What different? How? Sure, yeah. But what I mean is, you're trying to undo all the things that are being done to say the x, right? And so what would you do with your normal order of operations? You're trying to undo stuff. Would you do PEMDAS? Or would you reverse it? Yeah, if you're undoing it, you want to reverse that, right? You want to work on it by reversing that order of operations. Okay? So the first exercise here, they're just asking you to say what is being done to the x. So we have this 5x plus 3 equals 23, right? Okay? So list the order of operations been done to the x. So what's the first thing in PEMDAS that if you were to put a number in for x and evaluate it, what's the first thing that would happen to it? So I put a number in here. You'd multiply it by what? 5, right? So the first thing being done to x is it gets multiplied by 5, right? Multiplied by 5. And then what would you do after that? Then, yeah. And then added, 3 is added, right? Add 3. Like if you were to plug a number in for x and evaluate it, right? Okay? So now in part B, they're asking us to do what? Bless you. Solve the equation by reversing what's been done to the x, right over here. Right, so when we solve it, the first thing we'll do is go order of operations backwards, right? And so what's the opposite of adding 3?
Subtract 3.
Right, so let's write it down. 5x plus 3 equals 23. So we'll undo the adding 3, right, working backwards by subtracting 3 from both sides of the equal sign. How about 3 would be the thing we want to subtract from both sides of the equal sign, okay? Which leaves us with 5x equals 20. And now we undo, go back up. This one, what undoes multiplying by 5? Huh? By 5, right? So then we divide both sides by 5.
We did this last year.
Mm-hmm. Well,
The x equals 4.
yep. You guys need some help. Verify equation, see if they makes it true. Yeah, I did 5. No, I'm not going to do the check. So sick of that.
You're such a bad man doing that.
I know.
He's a baddie.
It's just,
Useless.
I mean, you could check it by just making sure you're being careful with the solution. Unless it says check, okay? All right, so solving equations by inverse. So inverse, right? Inverse means the opposite of what you did, right? What's the inverse of adding? Subtracting and vice versa, right? What's the inverse of multiplying? What is the inverse of squaring something? What undoes squaring?
Oh, square root.
Square root. Hey, what undoes square root? Squaring. Yeah, okay. All right. So let's go down here. Find the value of x. So just wait. First evaporation. So, okay. So what happens to x, or what is happening, right? So what's the first thing that you do to that x as they have it written? Okay? So the first thing is subtract 3, right? So subtract 3. And then what? Then it gets divided by 2, right? Divide by 2.
Add 7.
And then the last thing was to add 7. Okay? Now we reverse it. So we do the inverse of each one of these in reverse order. So let's write this guy down. x minus 3 over 2 plus 7 equals 23. So what should we do first to solve it? No, we got to go backwards.
Subtract 7 from each side.
Right, subtract 7 here from each side, yep. That leaves us with x minus 3 over 2 equals 16. Now what do we do?
And then you multiply by 3.
Because that undoes the dividing by 2, both sides. Watch how I do this. 2 times this side times 2, right? These 2's will cancel, won't they? So we're left with x minus 3 equals 32. Now finally, what do? The inverse of subtracting 3 is adding 3. So plus 3 there, plus 3 there. So x equals 35. Well, remember, this will all be on Teams if you get behind, so you don't. Oops. Okay.
Amy, are you using a highlighter? Looks like you're using a highlighter. That was the word.
Okay.
I was like,
Anyway, let's move over to part B. You got that there? Yeah. Part B. So let's talk about what's happening to x. Think about PEMDAS.
distribute the 4 to what's in the parentheses.
Well, that's what, right? Yeah. It could be, but like if you were going to plug in, say, a 2 for the x, wouldn't you just do work inside parentheses first, right?
Really?
So if we do it that way, what's the first thing that gets done to the x? Add 1, right? Add 1. And then what? Make that look like a 1. Multiply that result, so multiply by 4. And then what?
Add 2.
Scratch that, what? Subtract 2, right? Sure. Subtract 2. You're going to minus it? Is that what you're going to do? All right, so we're going to solve it by working this backwards. So 4 times x plus 1 minus 2 equals negative 6. So now we add 2 to both sides. All right, so we get 4 times x plus 1 equals what? Negative 4. I mean, you could distribute here and do it that way. That's one method, right? I think it's just easier to do what at this point? The opposite of multiply by 4 would be what? Divide by 4, both sides. Now these guys will cancel. And you got x plus 1 equals what? And finally what? Opposite of that, what? So minus 1, this one there. So x equals negative 2. All right. Any questions? So solving an equation, you're just doing reverse order of operation. All the inverses of what was done to the x, or whatever the variable happens to be. Good. Good. All right, we got this? On the next page. Solve the following. Now, hey, so this one's going to kind of like what you were talking about, where you could distribute or do it the other way I showed you. We're going to have us do it both ways, right, to solve it. Okay. So in the first way. Okay. First way, we're going to kind of do it like we did the last time, and then the second way, we're going to solve it by using the distributive property first, okay? And hopefully, it'll come out the same, right? Because they're both valid. So what are we going to do to this side first to solve it? Subtract the 8 from both sides, right? So we got negative 2 times x minus 4 equals 2. What now?
That's
Oh! Negative 6. Now what? Do what? So adding undoes multiplying? Divide by -2, right? Now they'll cancel. So x minus 4 equals +3. Finally, add 4 to both sides. Circle your answer. Huh? Huh? Yeah. Okay. Now they want us to distribute first and solve it that way. Let's see if we get the same answer over here. So now we're going to do this first and combine some like terms, right? Because this is valid too. So let's distribute that. What do we get? Plus 8 plus that 8. Now, kids here, they'll start like subtracting 8 from both sides. Get everything combined first. It's so much, yeah. So -2x plus 16 equals 2. All right, what are we going to do first?
I feel like that was easier.
Subtract 16 from both sides. So we got -2x equals, now, divide by -2. So x equals +7 again. They're both valid. And sometimes it depends on your preference and the type of problem you're solving, right? Some problems will be a whole lot easier to do this way, and some you'll be more comfortable doing that way, okay? You'll just have to feel that. There's like no hard and fast rules of when you should do one or the other, but you just start to get a sense of it, okay? Let's see what they got down here. Exercise 4. Everybody got this? Set up equations and translate the following verbal phrases into math. I know you guys love these. So 10 less than 5 times a number results, well, we know that's an equal sign, in 35. 10 less than a thing. What's the thing? So 5 times the number would be 5x. 10 less than that would be
5x
minus 10. Results equals 35. Right? What's the number? So what are we going to do? Add 10 to both sides. So 5x equals 45. 5 by 5. Yeah. And so again, because at some point, like all these like teeny little steps here that we have to show, it's like almost an arduous task, right? Yeah, for now you do, right? But at some point, we'll all assume we're all proficient on the same page with this, right? So, like, you could go right from this line to this line to that line without showing the plus 10 divided by 5, right? A little later on, right? Okay? And then when you get into higher math classes, it's really like even less. Well, there's more work to be done because there's more concepts, right? But less of the nitpicky little stuff here, but just keep that in mind. For right now, I need you to show all that, okay? What's in part B? When 3 times the sum of a number in 7 is increased by 10, the result equals 4. Now, I'm going to let you guys think about this for a minute, okay? See if you can turn these words into an expression that, well, equals 4. Yeah,
Make sure you record.
thank you. The sum of a number in 7, right? That would be x plus 7, right? 3 times that. And then increased by 10, so it's plus 10 equals 4, okay? And has anybody solved that yet?
Yeah.
What'd you get?
X equals 9.
Nope, but thanks for playing. Nope. You're all wrong, flat wrong. I love being able to say that. Makes me feel better than you.
What I'm thinking is -9.
Negative 9. How many got negative 9? Yeah. And sometimes you kids like will just say something like drop the negative. Like
No, I
it's
forgot
just
that
just
30.
a significant little mark in front of the number.
I forgot that -31 4 minus 31 is a negative.
Yes. So like, the difference between, like, if you just, here's what we did, right, but a lot of kids will just drop the negative, like, the difference between, if you say 9 when it's supposed to be -9, you're actually off by 18, aren't you?
Yeah.
Okay, so, did you distribute first?
Yeah.
Yeah, I'm gonna do it the other way then,
Really?
really, just for spite, right? And now I'm gonna divide by 3 if I'm doing it this way. So they cancel, so we get x plus 7 equals what? -2, and I do this, undo that there, -9. Or you could have done it by distributing. I'll do that real quick. Right, or 3 times x plus 7 plus 10 equals 4, right? You could do 3x plus 21 plus 10 equals 4, but don't start adding and subtracting to both sides until you get everything like terms combined, right?
3x plus 31 equals 4 divided
Right?
minus 31.
So now we subtract 31. So 3x equals -27. Divide by 3. Either way. Okay? I don't think there's any, are there any reading questions? There's not.
We're all done next time until then.
I will, listen, I will say, like, the problem set, like, all the numbering is all monkeyed up. If you look at it, it goes 1, 1, 2, 3, 4, 5, and then DE 6. So, but the important thing is, look in problem number 1
For what one?
on the problem set.
2.1 or 2.2?
2, 2, 2, 2. You see where it says in the expression x over 5?
Yeah.
There's like a little artifact. It looks like it might be an equal sign. It's not. It's -3. Okay? It's minus x over 5 minus 3. But it kind of looks like an equal sign.
Wait, we're doing this one too?
This is the homework, Tammy.
Yeah, we're doing both of them.
Yes, yes. Okay?